Okay, so in this demonstration we will find the derivative of y equals tangent of x, y equals tan x. Right? So we know that the derivative of sine x is the cosine of x, and d by dx, or the derivative of cosine x, equals minus sine x. Now we've seen that before in the other notes, and so what we're going to use is the fact that if we have y equals tan x, well, we know that tan x is sine x over cos x. So we've now got good old, where are we? We've got a quotient rule. Okay, which, if you remember, was v derivative of u minus u times the derivative of v all over v squared. So we're going to use that fact to find the derivative of y. So if u, let's call this one u and this one v, okay, then clearly the derivative of u is u dash, and the derivative of cos x is going to be the v dash. So let's just plug in those values, and we've got v, which is cos x, times the derivative of u, which is u dash, which is cos x again, minus u, which is sine x, times dv, which is minus sine x, all over cos x squared. Alright, let's simplify that now. We then have y dash equals cos squared times cos squared is cos x squared. We've got a negative times a negative, which is a positive, so we've got sine x squared all over cos x squared. Now don't be tempted to cancel out the cosine x's, please. Thank you. Let's rewrite that into a form that we know. We know that cos x squared can be written as cos squared x plus, similarly, sine squared x all over cos squared x. Please don't cancel cos squareds. Now, we know that in earlier work we've seen that sine squared theta plus cos squared theta equals 1. So that means sine squared x plus cos squared equals cos squared x equals 1. Sine squared anything plus cos squared anything equals 1. So we end up with y dash equals 1 over cos squared x. Now, 1 over cos x has a name. It's called the secant of x, or simply sec x. So what we end up with is that the derivative of tan x is 1 over sec squared x. Okay, and that's it.